If you guys can see in here, just let me know in the Slack channel. Can you turn that one on? Yeah, Christine's test. All right, we're gonna get started. What is that number? 8.
Everybody does it. You realize you're
testing. All right. So, thank you everybody for coming out. I know it was very last minute as far as the topic was. We're still trying to find someone else to speak, but unfortunately, you guys are going to get me instead. Take this mute off just in case they say. So today's topic was going to be it was a toss-up between 2 different topics: automated testing, or do you have 20 years of experience, or 1 year of experience 20 times, or 5 years of experience 4 times. Yeah, and quick with the math. Good job. But we're going to do automated testing because I think the experience one, I think, requires a bit more time to put into it. I want to make it polished. I know some of you have heard parts of it already. That's one that I've really been thinking deeply on. I have probably close to 20 years of experience writing code, but maybe 6 of those years or more are the same. So you can't even count them. And that can easily happen to people, especially for you guys starting off. Just keep that in mind, because that the number of years of experience is not necessarily equal to what experience you actually have, because that can vary depending on how you approach your learning and your growth, that sort of thing. But that's another topic. Today, we're going to be talking about automated testing. Just to give a few disclaimers, I cannot spell. Most of the people that are already here have been here for a while. They already know that. So don't point out spelling errors. They're there. We know they're there. We also have a backlog as well. And I'll send a link out for that. There's probably about 40 or 50 topics in the backlog. So if you want to present, but you don't know what you want to present on, there's a lot of options in there. Anyone can present. Just shoot me a message. We're going to have a few speakers externally that are coming up, thanks to a few of you guys here as well. That's going to be useful. We're also going to have a session with a bunch of lightning talks. So a lightning talk is like a 10-minute talk, 5-minute talk, something like that. We'll have a nice spread of food as well. It'll be like a real social kind of event with some learning sprinkled in. Right? So that'll be pretty cool. I believe that one's going to be either 13th or the 20th of July. Depending.
It's already booked.
Tessa's book. When is she?
20th.
20th. So it'll be the 13th. So we're working around that sort of thing. So getting to today's topic, automated testing. So this is going to be kind of a discussion between the group. Like, I have some thoughts, but I want to get your guys' thoughts as well. This is actually, a lot of this came from things that I was thinking about before, and also a very long discussion in the topic code Slack channel that happened maybe about a week or 2 ago with me and a few other developers from Langley, I believe, or some other center. Can't remember where they were. Interesting discussion. So I'll try to put a link into that as well, just so you can kind of go back and look at it. So what are automated tests? What are automated tests? That's a question. Anyone have any thoughts? So simply put, go ahead.
Things that can be ran over and over again consistently that are determined solid.
Okay, that's accurate. Simply put, automated tests are just code that exercises other code. Right? It's just code that you write to test other code that you've written or someone else has written. And that's really the sum of it. There's multiple variations of that, multiple flavors of that, but it boils down to it's just code that's testing other code, right? So if you can write code, you can write tests, right? So how many of you are actually writing automated tests today?
Yeah, I have them.
I mean, it doesn't count if it's not today. So no. How many of you are writing automated tests? generally speaking. Every year or two. Yeah. I guess that counts somewhat. No one else?
I just did it recently.
Oh, awesome. So you guys are really going to learn some things today then.
Yeah.
All right. I'll try to make sure I tailor it accordingly then. So why write automated tests? That's the question, right? Because you're writing code that's not really getting shipped to production. It's extra. Your manager comes to you and say, why are you spending all this time writing all this stuff that has no, in their mind, production value, right? It's not getting shipped to production. It's taking you extra time. A lot of times it'll take you longer to write a test than it does to take you write the implementation that you're testing. A lot of times too, you may have one function that you're testing, but you may end up having 8 or 9 functions to test that one function. All right. So there's a lot of extra effort that goes into writing tests. So with all of that, why would you actually write tests? So you want to ensure that your code works the way you expect it to. How many times have you written code and it's like you accidentally put a less than instead of a greater than, and then things did not work as expected, but it's such simple code, like obviously it's going to work, right? So it helps you to ensure that the thing that you think your code is going to do is actually what your code actually does, right? Because the computer is it's either true or false, right? It's not interpreting it, so to speak. It's actually running it, right? So make sure your code does what you expect it to do. This can be easily overlooked, as we kind of mentioned, with that less than or greater than, or something being true. I mean, compared against true versus it being compared against false. Seems simple, but it's useful. Another one is to protect against regressions. So how many of you have written code that worked today or yesterday, but then tomorrow it no longer works, right? So protecting against regressions, like that thing that was working yesterday, we know that it's still working today and then tomorrow and the day after that, right? So you may currently be doing some of this by like saying, every time you write some code, you fire up your application or whatever the case may be, and you test that thing that you're doing, right? You manually go through and test it. You click the button, you submit the thing, or you do whatever. So you're already testing. Everyone tests. If you don't test, then your end users test for you, right?
Or
But
Microsoft.
yeah, someone tests it, right? But the difference we're talking about here is the manual testing versus the automated testing. So for example, if your application lives long enough and it's big enough, then there are going to be parts of your application that you just do not test over again when you're writing that new feature. But you still need to ensure that that thing that you wrote before still works, right? And so that's automated testing can help you against that. Not just regression testing on the thing that you're working on now, but regression testing your entire application so that nothing falls back, right? Finding conflicting requirements. And this is an interesting one. Most times people don't think about this, but you get that manager that comes in and says, I want 2 plus 2 to be 4, right? And then later on they come back and say, I want 2 plus 2 now to be 3.9, right? And so you write it the first time and it worked. You wrote the second one and it worked. But now there's 2 parts of your applications they're in conflict. So every time you get one to pass, if you have unit tests, then the other one should fail. You get that one to pass, and the other one would fail. You're like, okay, there's not a problem here in the logic of the code. The problem is in with the requirements that are being given. They don't match up. And that's an oversimplified case, but it happens a lot. It's like, think about it in terms of security. Like this person should be able to see this thing in this scenario. And then another scenario, they should not be able to see it. But those 2 scenarios are in conflict, right? So every time you get one test to pass, the other one fails, and so vice versa. And then he's like, okay, there's a problem here in the requirements as defined. And you can use that as a flag to go back to your manager, whoever's giving you requirements, and saying, this thing that you told me to do 6 months ago and this thing that you're telling me to do today are in conflict. What do you want to do? And they're like, oh, yeah, that old thing is do away with it, right? But at least you know now. So or this new thing, oh, I forgot I told you the old thing. Don't do this new thing, whatever. You can use that as a way of finding conflicting requirements, right? The communication about how things work. So how many people look at documentation to figure out how something works? How many people write documentation? How many of your documentations are out of date? everyone should raise their hand, right? Your documentation is always out of date. After you wrote it, it pretty much went out of date. But your code is living document. Your tests are living documentation, right? If they are out of date, guess what happens? They fail and they tell you, hey, I am out of date, right? So your code can be living documentation that you know is accurate and you know is true, right? So that's another reason to write code, write tests. All right.
You forgot one.
Oh yeah, by all means. And I'll enjoy my pizza while you're talking.
Depends on how you look at the way you develop. Test-driven development.
We're going to get to that.
Well,
We're jumping ahead. Go ahead.
I was going to say, if you look, you should be in test-driven development, you write a test before you even write a single line of code. And is it Kent? Is his last name Kent or his first name's Kent?
Kent Beck.
Yeah, Kent Beck wrote the book on test-driven development 15, 20 years ago.
It's been a while. So, yeah, we're going to get to that. You're jumping ahead. So what kinds of tests are there? What kind of automated tests are there?
Unit testing.
I heard unit testing. That's like everyone's favorite.
Integration test.
Integration tests. What else? End-to-end tests.
Load test.
Load tests.
Good tests.
Performance tests. What?
Good tests.
Good.
Bad tests.
There are those. Yeah. We're going to talk about that too as well.
In cases or streams.
Yeah. All right. So you guys named most of the ones I had here. So unit tests is the one everyone knows. And they say that's supposed to be like the great portion of your pyramid. Everyone heard of the testing pyramid before? Usually it has 3 types of tests on there. And those would be the ones that we talk about mainly today. Unit tests, then integration tests, and UI acceptance or end-to-end tests. All those are the same thing, different names for the same thing, right? So they usually say that you should have, most of your tests should be unit tests, and then a smaller set of tests should be integration tests. And then above that, you should have your end-to-end or acceptance tests, right? A couple other types of tests, property tests. And I won't go into details on these. Fudge testing, this one's interesting, right? Where it's like I have a test and then I change the code and see if the test fails. If the test doesn't fail when the code was changed, then the test is not testing the code properly. All right, so that's an interesting one too. Load testing I heard before as well, like making sure your application can survive the load that it's expected to be under. So if you're like, all right, go ahead.
Yeah, we found out yesterday we had a particular URL that was loading fast, and then we found out later it was loading fast because of cache.
Yeah.
Without the cache, it was taking 7 seconds.
There you go. Yeah.
So we had no idea. So somebody, because there was somebody pinging it with a script that didn't have cache. That was like a load test.
Yeah. So that one's actually more like a I think it was the right term for that, because so the problem was not that it was falling down on load.
It was inconsistent. Sometimes
it was inconsistent because it was being cached. So let's say, for example, you change it's more like a fudge testing where you change the input and do you still get the same output out? Or I can't remember the exact term for that, but it's not quite load testing. Load testing is going to be, it works when it's on my machine. I'm the only one hitting it, but then everyone in the group tries to hit it and it fails, right? Because it wasn't designed properly. It runs out of memory, or something like that, right?
That would be like the properties test.
Yeah. So I'm trying to think. We won't spend a lot of time on it because we're not even going to most of these ones. Performance test is another one, right?
And you missed another one.
Yeah.
Security or fuzzing testing.
That's what fudge testing. I thought I lumped it in under that one. But yeah, there's a bunch of other ones. You can spend a lot of time going down a testing path. We don't have that much time, so we're going to focus in really on all these tests, and that's unit tests and integration tests. We'll mention a little bit about acceptance and end-to-end tests as well, but we're really going to focus in on those 2 primary ones because those are probably the ones you're going to be writing the most, right? So I may have to go back to this and define these, but I think I might have defined them later on. So that was a late night. All right, so no, let's just do it now. And if I had to go back, if we show up again, we'll just skip over it. So what is the difference between unit tests, integration tests, and acceptance tests? Because I think this is critical. Any thoughts on that? Dependencies, and that like meaning what?
As you go up the chain, there are more dependencies. For example, with the UI acceptance, you're depending on a browser environment, whereas with a unit test, you're just depending typically on the language or the modules that are probably easier to see in code. But I guess, yeah, integration test is somewhere in the middle where probably testing code that integrates with other parts of the system.
Yeah, that's a pretty good definition. Now, here's the thing. Depending on who you're talking to, these things will mean different things, right? And that's one of the reasons why I asked for a definition of what you guys think. And frankly, none of it matters, right? Don't get into a semantic war or holy war over, is this a unit test or is this an integration test? Does it test the thing that you're trying to test? Yes or no? That's all that matters, right? But so Kent Beck or whoever, one of the first pioneers with unit testing, they define unit testing as a test that doesn't affect other tests, which to other people can be either a unit test or an integration test, because it has nothing to do with the dependencies. It just has to do with whether or not this test affects the test beside it, right? Other people will say a unit test is only one function or one class and has no dependencies, and mocks or fakes or stubs or whatever it used. And we'll talk about what those are later. But the point of the matter is none of that really matters. Is your code, remember, we go back to that simple definition of what an automated test is. It's code that tests other code. So whether it's a unit test or an integration test, as long as it tests what you're trying to accomplish, then it doesn't really matter. So what's more important, and I think a more useful way of actually segregating your tests is your test fast? Is it slower? Or is it slow? Right? Oh, let's take that on its head now and say, let's redo that pyramid and say, majority of your tests should be fast tests, right? Less of your tests should be slower, and very few of your tests should be slow, right? And why does that matter? Because that determines how often you actually run your tests. If it takes you 20 minutes to run your test or 3 hours, how often are you going to run your tests? Not very frequently, right? It also determines when you run your tests, right? You can have your tests, if all your tests are really fast and they all execute within a second, then you can have your tests running every time you build your code, right? You can get instant feedback as to when something breaks before you write a whole ton of code, right? If your tests take a day to run, what's the likelihood you're going to test after every line of code? You might not even test once a day if it takes your test a day to run, right? So how often how quickly your tests run will determine how often you write your tests, right? Or how often you run your tests. Also determine which test do you run. So if you have a bunch of slow tests, then chances are you're not going to run them that often. You may run the faster ones, but then the problem may come up later on. So you could have shipped your code, you got thumbs up on it and everything else, just to find out that there's some huge things that you broke that you now have to go back and look at that again, but you've already moved on to another problem, right? So it's harder for you to kind of pick up where you were with that and fix it because you've moved on to something else. So trying to aim for most of your tests to just be fast tests, whether that's an integration test, a UI test, or a unit test. Doesn't matter as long as it's fast, right? That makes sense? All right. So TDD versus BDD versus TND. Lots of acronyms. You're at NASA, so I'm guessing you're used to it. Any thoughts on what those are? He already mentioned TDD.
Development.
Yeah, it's hard to get that last one, but all of you do it.
Test never development.
Yeah, test never development.
Okay.
All right.
But you
just said that's impossible. Production test development.
Actually, I gotta rename that then. Test manual development is what that is called. All right, so we're going to run through those. So TDD, test-driven development. Anyone ever heard of red-green refactor? So this is kind of, what's your name? I keep forgetting.
Yeah.
Jim helps me out a lot, and my RAM.
Does it have to become Joe?
No, Jim, it was RAM. My RAM is small, and it just kind of. All right, so Jim mentioned this already. You write the test first. That's the red stage, right? So if I'm writing a multiplication calculator,
The 2 + 2.
yeah, a calculator application, right? Calculator class. The TDD way of doing it would be like, I write the test to say, hey, do I have a calculator? Can I, the calculator exists, but I haven't written any actual code yet. So when I run that test, what's going to happen? It's going to fail. Yeah. So that's the red portion. And then what I do next is get that test to turn green the easiest possible way that I can. I think I wrote that in there. All right. So you write a test with the behavior that you want. In this case, we want to make sure the calculator exists. Very basic, right? We write the simplest code to make that test pass, which means like instantiate a class, right? So that passes it. Now let's take that a little bit better. So let's do an addition program application, addition portion of the addition function of the calculator class, right? So I'm going to write a test that says when I add 1 + 1, if I give the add function 1 and 1, it gives me back 2. So what code would you write to make that work, given the TDD pattern?
You just call the function.
Call the function and do what? No, you write the function because the function doesn't exist, right?
Yeah.
But then you wrote the function and now
Return true.
return true would fail because I'm expecting 2, right?
Yeah, no, you return true if it equals.
Huh?
Return 2 if it equals. No, you turn true if it equals 2. If you pass 1, 1.
Okay, so you would write the add function and the add function would just say return 2, right? There's no code there, but guess what happens? The test turns green, right? So that is working. It's working code, right? It's a very limited use case, but it works, right? It only works in the 1 + 1 case, but it does work. Now, what do you do after that? You take that, you write another test and say, if I give you 1 and 3, you need to return 4.
Yeah.
So that test is going to fail. So now you have to get that test, the one that should turn 4 and the one that should return 2, to both work, right? And now you have to actually write some code, right? But this way ensures that you write only the code that's necessary in order to satisfy your requirements. So how many of you over-engineer your stuff? Right? This protects you against over-engineering. You are done when all your tests turn green. If there's a new use case, you write a new test, and when that test turns green, you are also done. Right? So I do this all the time.
But for this example, you would either, if you're going one test case at a time, you'd end up with your add function being just a long chain of if-else's, because that's the easiest way to add a new case.
That is true. That is
or
true.
You start and you have to do a completely exhaustive test, which will probably be automatically generating the tests.
So
and go through every single number.
That he makes a great point. So we missed one. So remember, we had red, we had green, but we missed one, and the last one was refactor, right? So now you have those 2 tests, but you have an if statement in there, or a switch statement, and you're like, this is ugly. Hey, switch statements. This is code smell. How do I refactor this so that it doesn't smell? You know what I mean? And that's when you get to your optimized solution. Right? That was a really good point. All right. So refactor, keeping your code, all your tests green, right? For the benefits.
That's when you can do the over-engineering.
Yeah, that's true. Try not to over-engineer. It's a bad thing. So you end up with high test coverage. And anyone know what test coverage is? Like basically it's saying, how much of my code is actually covered by tests? And people can get really pedantic about this. It doesn't really matter. If you have a high test coverage on your code base, chances are you're testing things that don't need to be tested. And we're going to talk about that later on, right? Smaller, you end up with your code being smaller and more modular because of how how TDD helps you to drive your code towards. So that's a good thing. Here are the risks, though. Your code can be optimized for testing, but not optimized for the end user, right? So your code all works, it's all functional, but it makes your end user jump through like 5 hoops, and that's pointless, right? That's not what you're optimizing for, not what you should be optimizing for. You can be testing the implementation versus the requirements, and we'll talk a little bit more about that. So BDD. So some of the problems that came from TDD inspired BDD, which came after, right? So BDD is behavior-driven development, and I'll send this link, the slides out to everyone afterwards. Actually, I forgot to say this, but if you're not on the mailing list and you want the information from this, make sure you write your email on the sign-in sheet, right?
Where's it gone?
It's right there on the page. So you can get it later if you want.
I'm already on that.
Yeah. All right. So what's interesting about this one is like you have the way these tests are normally written, they kind of almost look like English. It's like a way of you getting similar logic to the business, or similar language to what the business says. So the business here is in quotes. The business is whoever is giving you your requirements, so to speak, right? So you usually, the person that you're getting your requirements from tells you something, you translate that into code and you write it. But if you have the two of you speaking the same language, so to speak, then the business people can actually write the test for you. And there's a language called Gherkin. It's something like that. It's like given, when, then, that sort of thing. And there's English words in there, and you have tooling that will translate that into actual code, and then that code would execute. So if they need to change the way the test works, they change that Gherkin file, the given, when, then, it automatically generates the other set of tests. And then, so now you're testing more behavior versus actually testing implementation, which is good, right? All right. I didn't put this one in because I thought about it afterwards. So test after development. Some of us don't write tests before we do it, but some of us write tests after we've done it. So what's the risk here? Like, what is the benefits and what are the risks? What do you think?
Have something.
Yeah.
You have something.
Yeah, you do.
If you write tests after, then you kind of already know what you want it to look like. So you're writing the test so that it would work for what you just did.
That's true. That's actually in the slides too. Yeah.
If you write the tests afterwards, you're not really sure how well you're doing.
Yeah, you guys are right on it. You're right on it. So writing your test afterwards, right? Some of the risks, you're not sure if your tests are actually testing what you think is testing, because you didn't start off with that red state. You went straight to the green state. So let's say, your test in our math case is I'm testing that I return a number that's going to pass. But are you actually testing that the addition function works? Not necessarily, right? So you want to make sure that if you do test after development, which I sometimes do, that you make sure that at some point that test turns red. Even if you have to go into your actual code and comment something out, to make sure that that test turns red and then it turns back green. So it's actually testing what you're trying to test, right? And there's some nuances there, and we're going to talk about those in a minute. So the other part is you may never actually go back and write the test. It's working. Ship it. Right? So you may never actually go back and write the test, which happens a lot. So there's a risk there as well. All right. And then TND, test never development. Don't do that. Try not to do that. It happens. You're running up against a deadline. The first thing to go is going to be a test. But try not to, because it doesn't make you go slower in the long run.
Shouldn't that be flipped? development, never test.
Didn't I say there's gonna be typos? And not to point them out. This was a test and you failed.
That's not a typo. He's
I don't know. I'm just,
wrong. He's just wrong.
Hey, I got a question.
it was a test for the test. All right. Yeah, go ahead.
So like, let's say you're in a situation, you have a tight deadline. Just assume that you don't have the time to write a test.
Mm-hmm.
It gets released, and the manager's like, okay, we're good to go. On to the next project.
Mm-hmm.
What do you recommend? Or what would you do in that scenario?
On to the next
Say, I'm
project.
gonna write this down. I'm sorry.
On to the next project. All right. So here's the thing. One of the best ways to enable yourself to do the test is not to even tell your manager that you're doing the test, right? That's just a part of you writing the actual code. That's a part of you doing your job. Now, if you go to them and say, to a manager and say, I need 30 or 40% more time to do the thing that's not necessary for this thing that gets shipped, any manager is going to tell you, do not do that thing, right? But if you say, I need this amount of time to do this properly, then they'll say, do what you need to do, right? That is below the abstraction layer, right? If you make a choice as a technical person, say, I'm going to forego this particular part of the testing, and I accept that risk, because you know how risk management, right? So we're going to launch a satellite. No satellite gets launched without something in there saying this is not quite right, right? But the risk management says is that, is it within tolerance levels, right? Do we accept that risk? And as long as you can accept that risk, right, then it makes sense. Now, if you're writing the autopilot for the plane that I'm flying on, please don't ship it without the test, right? The risks are really, really high if that thing fails. If you're writing a blog, you're writing something on your website, and you don't write tests on it, or some portion of the application that, if it fails, we get an error, but it's no big deal. Then use your best case judgment on that. But I don't think, I don't have 100% test coverage for all the things we write. But for certain portions of it, and we'll talk about it in a minute, I'll show you some examples. I don't ship it without the test because I just don't trust myself to do so. It's too critical to the application, right? Mocks and stubs. Anyone heard of these? Everyone has. What do you think it is?
Essentially recreating mocks.
Similar, very close, yeah.
So a mock is like you're spoofing the functionality of some other service or function or whatever. And a stub is just not even spoofing the functionality, just like the endpoint of it. Similar things. Tend to think of mocks more as like, I'm going to mock this service, like the stuff I'm downloading from the web, for example, versus a stub would be, I'm just going to insert this. I'm going to expect it to call this other function. And so I'm going to have this stub here that doesn't actually do anything. Then check to see if it called that.
Okay, cool. All right. So stubs are basically code that you write yourself to stand in place of the implementation, right? So if we had that calculator class and we wanted to test the multiplication function, which calls the add function, but we didn't actually want to test the add function, we can write a stub. Well, let me take that back. The calculator class called another class for some strange reason, and we didn't want to test that guy. But we wanted to every time our class called that class, we got back a certain response. Then we just write a fake class for that one that doesn't have any logic in it, but just returns what we needed to return. And then we insert that as a dependency instead of the actual real thing, right? So that's going to be our fake class. This is the code that you write, but it's just going to be a dummy thing. It doesn't have any actual logic in it. It just returns what you want it to return, right? Mocks are very similar to that, but they're usually going to be given to you by a testing framework of some time, right? They also implement the same interface, but they have extra benefits to them, which I think so you can determine what the output is on a per call basis, right? Whereas our stub is just going to return some simple logic, simple data. This one we can say, in this use case, in this test, I want you to return this, and it'll do it for you, right? You can usually inspect what kind of properties or parameters have been passed as well. So like, I'm going to assert that when this function, this other sub thing gets called, that it got past these values or whatever the case may be. You can even determine what gets passed back based on the values that you pass it in. So mocks can be really kind of complex. You can test that the mock was actually called. You can test how many times the mock was called, right? So let's say you're doing load test and you're like, how many times does this one thing get called? And it calls 10 million times. You're like, okay, if this ever gets called more than 5,000 times, fail the test, or whatever the case may be, right? What are the risks? What are some of the risks with mocks and stubs?
By definition, another implementation is not going to have identical behavior.
That is so true. That is the primary risk, right? Anything else?
Take a lot of time.
Actually, they usually take less time, but you want to avoid testing your mocks. Let's say, for example, and this is in the discussion that we were having on Slack the other day, someone's like, "Oh, do the mocks, do the stuff." They were gun ho with the mocks and stubs. And I'm like, okay, what happens if you have a class that returns a date and the date is formatted month, date, year, right? But then later on, you actually change your code so that it changes and it gives you time or it gives you the date in a different format, but you don't go back and update your mock. So now your code that you're testing and that has that mock as a dependency is testing the mock versus testing your code, right? So all those tests, when you ship it to production, all those implementations will all fail in production, but they're green in your tests, right? Because they're depending on a lie, right? So you want to make sure you're avoiding testing mocks. Testing your mocks versus testing your code. Again, it goes back to ensuring that they're not out of date. So my particular opinion is you favor integration tests over unit tests, right? Integration tests basically, this is out of order now because it was getting really, really late. Pure functions. Anyone know what a pure function is? This is interesting because in that conversation I was having with
Doesn't have any side effects.
Yeah. So anyone understand what he just said about side effects?
So that means that nothing outside the function got modified or changed.
Mm-hmm. Yeah.
Like no data, that includes database, other variables outside of the scope.
Mm-hmm.
It just, and even the inputs cannot be modified.
Close, but most of it was there. So that's what they've mentioned is one half of that. There's another half to it.
And for every given input, it has to have the same output every single time.
That's the other half. So let me translate that into layman's terms. You only depend on your inputs, right? So I'm not reaching out into global scope anywhere and pulling something in, because if that thing changes, then now the same inputs don't produce the same outputs, right? And I don't affect the world outside of what I return, right? So think of what an actual math function does. Like in math, you give it some inputs, and out comes the output, right? It doesn't change something outside of that function. You want to aim for as much as your program as possible to be pure functions. And why is that? Especially for testing, right? They're easier to test, right? They're so much easier to test. They're composable as well, and this goes beyond testing now, but they are so much easier to test. They have no, if I give you one and I give you two, and you're a pure function, and you give me back 3, every time I give you 1 and 2, it will always work. If you're not a pure function and you're somehow depending on some number that gets set, like you say, you're memorizing that number and you put that number somewhere else and then you add it back in again. Now, every time I give you 1 and 2, I'm getting a brand new output. That is very hard to test, right? What's even worse, when you go through your code and you're looking through it and you're saying, well, this function is just getting something, so why? I won't have to look in there to see where my problem is. But it turns out that function is also setting something, and that's your problem. But it's hard to see. because it's doing something in the global scope that you don't expect it to do. So aim for your test, aim for as many functions to have pure functions as possible.
But pure functions, I mean, you cannot have a purely functional program
Yes.
that does anything.
Yeah, I'm about to say, you can have a purely functional program and just won't do anything useful.
I mean, if you
At
want
some
to be
point you
really,
have to.
really purely functional, it needs to not cause any processor wear or produce any heat or anything.
Now you're being pedantic, yeah. But yeah, you are true. That is so true.
But,
like you're gonna have to have side effects some point. You just want to push those side effects as far to the edges of your program as possible.
You don't have one thing that does like 5 other function calls inside of it statement that tells all that.
That still can be a pure function as long as that doesn't affect anything outside of the function that called it, right? Yeah. Yeah. So pure function does not mean that your function doesn't call or depend on other things, right? It just means that every time I give it input, it should give me the exact same output, and it should not affect anything outside of the function, right? And I thought this was interesting because when we're having that conversation, the developer didn't know what this was, and it's one of those things when you know something, you just think everyone already knows it. You know what I mean? But sometimes it's good to just point out those things. Make sure you're testing the seams as well. I was looking for some memes on this when I found this one. I thought it was kind of cool. So you have this guy, right? Hey, right? So this is unit test without integration test, right? Both of those things work independently. They do not work together as integrated, right? And that can be very frustrating. There's a bunch of other ones in there. If you just look them up, they'll find them all over the place. This is another reason why I tend to favor integration tests over just strictly functional tests. No, integration tests over unit tests. So for mocking things, you want to mock the things that you don't own or the things that are incredibly slow. Remember I told you about how the real separation should be fast tests versus slow tests, right? So things that are really going to be slow, like every test I write has to spin up a database and then do some stuff and then tear that database down, and then the next one spins it up and adds data in, and that's going to be really slow. That's going to make your test really, really slow. So maybe at that point you want to mock out the database or stub out the database, right? Other ones can be third-party APIs, right? If every time I press the button, it actually fires a missile, that's going to be bad. Right? That's going to be really, really bad. Or you're only test it once and then the world's going to end. Right? So mock out third-party APIs if you can, but make sure that you keep those mocks up to date. There are some tools, like I think in Ruby, they have a gem called VCR, where you can actually hit the API endpoint, get the actual result back, and then use that result in your test. And then every so often that you call your test, it'll just hit the endpoint and then give you back the results, so that make sure your tests are actually testing what it should be testing versus testing, again, the mock, right? So test, what do you want to test? So you want to test behavior, not your implementation. Anyone heard of React? Yeah, all right. So React version 16, they totally rewrote the entire UI library. And it was API compatible. You know how they were able to do that?
Tested the API.
They tested the API, right? They did not test the implementation that's internal to it, right? So let's go back to our multiply function. I think I have it in here, and it's not going to do it right. So I'm just going to go all the way through. The function is probably, I started writing it and then I stopped, so I don't think it's actually working, but the point is there, right? The multiply function, we can use the add function to do a multiply function, right? But if I, in my test how many times the add function is being called, and then I remove the add function, guess what happens to my test? It breaks, right? So I end up having a flaky test, right? So I can't refactor my code without breaking my test. Not that I'm breaking the logic of it, because 3 times 3 always returns 9. But I'm testing the implementation versus testing the behavior that I want. So a good way of kind of segregating the two is test from your public API in versus testing each individual function within there. How much time we have? One. Okay, let's start going a little faster.
Code is the opposite example because it's code that doesn't work, but it does pass the test because it calls add the right number of times.
Should work.
It
didn't return anything.
It doesn't sum up the adds. It just.
I told you. I didn't have time.
And so that would pass that test.
That's so true.
Because it's calling add.
I did that on purpose. Yeah, that's good.
How late were you up till?
It was like 1 o'clock.
I'm just going to assume that was intentional.
It was intentional. All right, so avoid flaky testing. There's a couple things there. Obviously, I didn't get my avoid flaky testing. Okay, yeah, avoid flaky testing should have been in there. Test. I think the hyphen is in the wrong place, so shift it to the right. So arrange, act, assert pattern. Anyone heard of that before? The way you can write your tests. And let me see if I can quickly show you. So this is a test. This is probably too small to see. Zoom it in. This is a part of a test suite for one of the projects I'm on. And I'll show you really quickly. The little green check marks is like, hey, you're passing. That one does not have all of them. This one does. So you see here, say arrange, and then it says act, and then assert. Arrange is basically set up my environment for the test. Act is me doing the test, and then asserting is saying, let me verify the results that I expect to happen. So that's a good pattern to have in your unit test or your integration test or whatever test. Set up, action, assertion, right? So that's very useful to know. And we'll come back to this test one in a minute. All right. So create a DSL. Anyone know what a DSL is? Yeah, domain-specific language. So it's a language, so to speak, that's specific to the problem that you're trying to solve, right? So think of a domain-specific language kind of like as, let's say you're in a ER or whatever. The things that they say in the ER is kind of a domain-specific language for the ER.
Just sounds like that.
Yeah, for the person that doesn't understand, but there's a lot of meaning in what they're saying, like code black, blah, 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 whatever, right? They know what they're saying, and there's a lot of meaning vested in that, but it's specific for their environment, right? So you can create a domain-specific language for your tests, right? And the usefulness of that is that it abstracts certain things away. Again, the implementation of how that test gets set up versus what you're testing. And I'll show an example of that in a minute as well. So we'll also show the system under test builder pattern, pretty useful. Deleting unneeded tests. So just because the test was there and it was useful today does not mean that you should keep it around forever. Once it's no longer useful, delete it, because now it's just a flaky test. It may start failing and you're like, I don't really care about this test. So you start ignoring it. But that's like that broken window thing where it's like one broken test, and like now there's 2, now there's 3, now there's 7. You don't want that to happen. Again, we talked about don't test internal implementation. For UI tests as well, you want to avoid that pixel matching, right? I rendered my UI and it looks like this, and now I snapshot that, and every time I do the thing, it should look exactly the same. Problem with that is if your UI is in on any type of flux, that test is going to fail like crazy. Like you change the border radius and it fails. You look at it funny and it fails. That gets annoying, and you end up just shutting your test off because like, well, it's not useful. So let's take a look at some of those. All right, so this one actually shows an example of some of those things. So this is where am I?
You do automatic UI tests?
I do not do many of those, no. That's why I said I was really going to focus on integration tests and the other one. So this test here is, a lot of these tests are from my security part of my application. So this is one of those things where I say I won't ship it unless I have the test for it because it's core to the security of the application, right? There's other parts I will ship without it, but these parts I won't, right? Actually, we'll leave this open. So because we're going to go to another test there as well. So in this one, it's saying get the security lock. The security lock is basically, in my application, a series of security rules that combine together to form whether or not a person is authorized to see something or do something, right? So this is testing the security lock. What I have here is a function that says get security rules, and I've encapsulated in that a bunch of generic rules, right? So every time I see that, I know that's going to happen. I have a parent list, some other things in there. So this is all my arranged stuff. So all this is getting the environment set up. You notice here there's a builder. So I created this class specific to helping me build the system under test for testing. It's not actually in my real application. It just abstracts away how I built the system, right? And then I can have these little things and saying, add these security rules to my environment, add this parent list to my environment. Now build that system, right? And however you need to build it, that's abstracted away from my tests, right? And then do the assertion here, test the results, and then I should get back 6 results. I should see certain things in my results. If all those pass, then the test then passes, right? So that kind of shows some of the DSL portions of it, right? But it can actually even be better than that. So one of the things I didn't realize I did, but I did do, and it was pretty nice because it's like it shows one. So I have 526 tests that are passing. Turns out I have 2 that are failing because I just did some refactoring the other day, right? And so these 2 tests are failing, I believe, because I didn't actually investigate. But I think they're failing because I changed the an internal implementation of how the class gets built, right? So if I go into the builder, let's say here, and I believe down here, I need to change how this controller is being put together. So let's figure out how the controller is being put together. Here are my requirements. I believe I had a new experiment item. Oh, no. Okay, I'm sorry. I did look at this and I forgot. So if I look at the test itself and I say, what is this actually telling me? It's probably hard for you guys to see, but it's saying that the procurement item service, it can't find an implementation for that, right? And so my unit test, if I just did unit tests, this would work. It would work fine, right? But because I'm using a IOC container or dependency injection, and I have not set this thing up yet, so when I ship this to production, it would not have worked. But because I'm using integration tests in there, then it caught that configuration mismatch in the unit test versus it catching it in production, right? Because this would all ship and it would have been fine. It would have compiled and it would have been fine because it does compile, but the configuration was slightly off. And so because we're using integration tests, and actually what we end up doing is the same configuration that we have for production, we use in our tests, right? The exact same configuration. The only thing that's different is the database and the third-party APIs. But everything else, like say, give me production, now swap out these little components that I don't want because they're too costly in my test environment. Now run it exactly as you would in production, right? So that's why it caught this configuration mismatch, right? So that's the beauty of actually running. You're running it closer to what you would actually, what your end users would run later on. All right. This last slide. So your tests are no good unless you run them, right? And sometimes in the heat of the moment, you don't run them, right? You just write the code and you wrote the test. You're already ahead of the game, but you did not run your whole test suite. And that's where CI systems come in to help you out, right? So if I wrote some code and I shipped it to be merged in, like I say, I'm putting in a pull request, then I can have my CI system always run that code, right? Let's see, we have one here somewhere. So this is, ooh, and it's failing too. I think it's going to show me my test is failing. So every time we push code to our central repository, all of our tests run. right? And it runs in an environment outside of my laptop. So just in case there was some environmental thing that was happening on my laptop that made it work, but would not work in another environment, then we'll catch that in the CI system. I don't have to remember to run this all the time, because if I don't run it, it'll run it in the CI server, and I can't merge it in until all these things pass, right? And so all these requirements are satisfied, which is like, for us, if anyone writes a comment on there, then you have to resolve that comment before you can merge it. You have to test, all your tests have to pass, and your code has to build, obviously, right? But all those things have to happen. And if it does not happen, then I get a nice nifty report along with an email saying, hey, dude, you screwed up. So my test assemblies, let me go back actually. My test assemblies did not work. Where is that? Let's go here. So I can see out of 750 tests, 748 of them passed, but 2 of them failed. And I can go to that detailed report and say, okay, which of these things failed, which is the ones I actually saw on my laptop. And it gives me a stack trace and other information along with to help me find when this happened. Another useful thing I like about this too is that it tells me when that test started failing. So let's say the test is failing, but it was failing a week ago. And chances are it's not the code that I wrote yesterday that's causing this to fail. It was the code that I wrote a week ago that when this test started failing. So now I can find the commit. Actually, it's tied to the commit anyway. But I can find the commit and say, here's what's happening. Here's when the test started failing. So useful things there. I think that was it for the slides. Any questions or anything like that? I think we're a little bit over. I wasn't looking when I said any questions, so I guess I should look up. No.
Okay, so
yeah,
the reason my project doesn't have a lot of tests is the stuff that's easy to test. It's not terribly useful to test. And everything else
is really hard.
Requires it's Angular web stuff using like nested scopes, and it's got all these services that all have to have loaded stuff from the network.
Yeah. So that brings up a really good point. Does anyone have any opinions on that or why that might be? Yeah.
I think that's the general problem with libraries in general. Like I have the same problem with React in that it's very easy to write and spin up and get your code to work. But when you look at how to actually test React or Angular code, it's not something you can get easily. You probably get it on Stack Overflow, and you find people. Oh, this is how you test it with this dependency and that. But the code it's hard to write.
Yeah.
Just the test code.
Yeah.
Because then you got to bring in other libraries that do the mocks for you.
Yeah.
You can't do that by hand.
Yeah.
Right?
That's a good point. Good point.
But it doesn't mean you shouldn't do it. It's just harder.
Yeah. All right.
For my thing, it's like I just added like we use Angular, and just adding like one third-party library. I looked at like what people were suggesting to test, and it was like it would have taken like 3 or 4 days of development. It would have taken a lot for our project.
Okay. So let me ask you all three of you guys. Any other opinions on that? When did you start trying to test your code? At what point in their life cycle did you start testing?
Well,
After I started my project,
My feelings hacked.
Before that, please.
I got it working but now I'm in a phase where I'm looking at the suggested testing library, which is Jest.
Yeah.
So that, I mean, there are very many libraries, but that's the one you should for me. But again,
so I work.
I'm going down that path right now.
Okay.
That's all.
At what point in the life cycle in the project? Like how long is the project?
This is test after development.
Yeah. All right. So the reason I brought that up because I work closely with another developer, and he used to curse testing. This morning in stand-up, his customer said they want more testing. He was like, yeah. You know what the difference between then and now was?
Before he started writing.
No, still tests after. But the point is he now understands how to write code that's testable. Right? So if your code is hard to test, it's not architected properly. The test is actually telling you that your code is not architected properly. Right. So now when he's writing code and we go through code review, and I'm like, You're reaching out to global scope to get this thing. That's going to be hard to test. Don't do that, right? You're tying all these things together in a very complex way, and it works, but it's going to be hard to test, right? So if your code is hard to test, that in itself is giving you an indication of the quality of your code, right? Some things are just hard to test, and complexity. Some things are just complex, so they're just going to be hard. I'm not saying every test should be easy, right? But if everything is hard to test, then it's telling you something about how it's architected. If it's really hard to test like that, then it's probably hard to refactor. It's probably hard to update, right? It's probably a lot of other things that you don't want, right?
Well, yeah, I would push back on that and say, well, show me the Angular test for Hello World.
I have some,
Directive, right?
yeah, I have some tests in mind for Angular as well.
Right. You see that
It
test itself is kind of
It's
verbose.
pretty well.
Yeah, so there's some setup, and that's where I think the I'm sorry guys, but we might lose you online because my battery's running really low. But that's where that mentioned that builder pattern and that DSL. We didn't get a chance to really dive into it as much as I think we should have. But all that verbose setup, abstract that away into something else, so that your test itself is nice and clean. It just says add this thing, run this function, assert this thing out. Now, to get that thing set up the way you want may be complicated, but it's the same way for every other test that you're going to write for that particular thing. So abstract that thing out to another builder class. And if that thing ever has to change, let's say you're changing from Mocha to Jest or whatever, then you change that one class or that one builder thing, but the logic of your test doesn't change, right? And that's how you get around that flaky testing thing, where it's like, this thing is really hard. Or, if I change this one thing, now everything breaks. Like, for example, I didn't have one in the example itself, but